Okay, welcome back. In this short video we will look at the gradient of a line. So gradient is essentially a technical maths term for how slopey, another word is slope, or steepness of a line. So essentially the gradient is the formula equals, and you may have come across this before, rise over run. And what that essentially means is, if we have, there's our number plane, let's just label X and Y, and if we have a line like that, so rise essentially means if we measure the distance in the X direction and the run, did I say X? I meant Y. So rise is how far up it goes in the Y direction, and run is how far it goes in the X direction. And the slope is talking about how steep. Think of walking up. If you were walking up this hill, the gradient of the hill is for every however many meters you go this direction, the hill goes up. So a really steep hill has a bigger gradient. Okay, and something to bear in mind is if we have a straight line, it doesn't really matter if you measure, for example, this height over this is essentially the Y height divided by the X run. Doesn't matter if you use this one or a bigger. So imagine making a triangle. If I kept going, we have this triangle overrun that way. So it doesn't really matter which distance you use, as long as you're consistent with the triangle that you make from the graph. So there is also a formula, and this is what we're essentially going to be using a lot. And this basically, if you know this coordinate and say this coordinate, it allows us to work out that rise over that run. And it doesn't really, as long as you have 2 points on the line, it doesn't really matter what points you use, but it allows us to plug in those coordinates. So if this coordinate was, let's change colour, we'll call this one x1, y1, so that's point 1, and if this was point 2, we'd call that coordinate x2, y2. So think of it that way. And our formula that we're going to be substituting these values in is y2, take away y1, divided by x2, take away x1. So what that essentially does is, if this is 0 and this full distance is, say, 10, but this point here is at, let's say, 5, the x value for this is 10, but the x value for this is 5, let's call it 6, just so we don't get confused. Then what this formula does is it it subtracts this 6 from the 10, and it lets us know that this space in between, this run, is 4. And the same in the y direction. It's this y value, subtract this bit here, and it tells us that corresponding height of the triangle. Yeah, so I think the best way is to jump in and have a go at some examples. People tend to mix this up, so it's always the 2 y coordinates on the top, the 2 x coordinates on the bottom, and I think the best way to sort of think about it is that there is this point, x2, y2, and those numbers there is this point 1 over here, x1, y1. It's very easy to get confused, have them round the wrong way. You need to be very careful. So the first few examples, let's just rub this out. First few examples is V2.3, and I photocopied these so we can just, because we are essentially using just the pictures, we don't know any numbers, and I'll talk about this information in a little second. So the first one, this one here. What we're essentially doing is, between these 2 points, we are making a triangle. And we're just counting the rise over run. So in this example, we're going, the run is 1, 2, 3. So the gradient if we go rise over run, so the run is 3. I'll do that one first, and then we go up 1, 2, 3, 4, 5, 6, which is 6 divided by 3 is 2. So what that essentially means for this one is, for every step of 1 in the x direction, the line goes up 2. So if we come just 1, then the line goes through that point that is 2 above. And then if we go 1 more, it's 2 up again, and another 1, it goes up 2. Yeah, the more we do this, the more it will make sense. Okay, so something to point out is, this one's not too bad because our gradient is positive. And that essentially means as we go up in the positive x direction, the line goes up that way. So the slope that goes up like this is going to be positive. As soon as it comes, do it with the pen, as soon as we're in this direction, as we go up in the x direction, the line's actually coming down. So we need to be really careful and think of, I suppose the best way to think of it would be to start with the point at the bottom, and as we go in the x direction, we need to realise that if that's positive and that's positive, then we're going to get a positive answer. If we start at this one, let's rub this out. So we're starting at this bottom point. We've got to go backwards to be able to reach that y run up there. So we're coming 1, 2, 3, 4, 5 backwards. So really we're going to write that run as a negative value. So in this second one, we're going 1, 2, 3, 4, 5. So that's -5 in the x direction. And then we go 1, 2, 3, 4 upwards. So 4/5, we could convert that to a decimal, -0.8. So negative essentially means that as we move in the positive x direction, the line is coming down. So we've got a positive slope and negative slope. When we have a straight line like that, the slope will be exactly 0. Okay, so we'll just do this one. We'll count the squares. So again, we're going, and notice how it crosses the axes. So essentially, we're just making this triangle again. So we're coming down to there. So we've got 1, 2, 3, 4. -5. 1, 2, 3, 4, 5. And we're going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that equals -2. So that means for every step we go in the x direction, the line comes down 2. One more step, down 2. One more step, down 2. It's probably a good way to think of it. Every step in the positive x direction we come down. Whereas this one, every step in the x direction we go up. I think that's really all there is to say. So, just to summarise what it says here, a positive value for the gradient indicates that the line is sloping upwards from left to right. A negative value for the gradient indicates that the line is sloping downwards from left to right. A value of 0 for the gradient indicates that the line is horizontal. So that would be, if there's our axes and we had a line like that. So that means every step we go in the x direction, the line goes up or down 0. Another step, it's still at the same height. So the rise is going to be 0. The larger the value for the gradient, the more steeply it slopes. So, okay, so that is, if you're given just a picture like that, the idea is count how many steps between the 2 points going left or right. So if you need to come this way, that's the negative x direction before you go up. So the rise will usually be positive. The run could be, in this case, positive, in that case, negative. Right, so I'll take that away and we'll have a go at using this equation. So it's probably also worth mentioning that the gradient, when we write it down as a symbol, although they use A in the book, by convention it tends to be called M. it's my understanding, although some mathematical historians would disagree, that this m stands for the modulus of the gradient. Because the gradient is essentially the slopiness of a line, but the modulus means the number that we use to describe how slopey. So it's the number we attach to this. So I will use m when we're doing calculations, just because it's the one I like. Okay, so these examples, find the gradient between, so we're going to be given 2 points, and we're going to be plugging them into this situation. -2, 3, and 5, 4. So, just so we've got some idea, -2, 3, so that's probably somewhere like that, and 5, 4 is probably somewhere like that. So think of those as our 2 points that is going to join some line that's got some particular slope. So now, just so you don't get confused, let's call this point 1 and that point 2. So just above, I'm going to say that's x1, y1, x2, y2. Now it doesn't matter which one you call x1, y1 and x2, y2, but what it will do is mean that these two from this one end up in this location, and these two will end up there, and if you end up with a negative slope, then depending on which way round you do it, you may end up with the negative number at the top or the negative number at the bottom. But just as long as you are careful when you first plug the numbers in, substitute the numbers in, you should be okay. Okay, so in this case, m, the gradient, just so I don't have to keep writing gradient. So y2 will be this one. 4, take away y1, take away 3, divided by 5, take away, now this one's negative, so I'm just going to plop it in brackets so we don't get confused. So then we just need to work out these little sums and then come up with just a single number. So 4 take away 3 is going to leave us 1 on the top. 5 take away -2 is like 5 plus 2, so that's going to be 1/7. I think we'll just leave it like that. So that means we need to go 7 steps in the x direction, and the line goes up 1. So essentially that distance there would be 7. That distance is 1. But this can sort of be proportional. So if we'd have picked, let's just try and get these on a line. Let's say that is on that straight line. Then that distance on the bottom and that distance on the top would still give us this value. So it's important that you are very careful with negative values. Just out of example, out of interest, if we were to swap these and call this x2, y2, x1, y1, so I'll do this one in red, sort of show you how this is going to eventually give us the same thing. So y2 would be 3 take away y1 is 4, divided by negative 2, take away x1 is 5. So this is going to give us negative 1 on the top, divided by negative 2, take away 5 is negative 7, and a negative divided by a negative is essentially a positive. So this is still going to give us 1/7. You can, and whatever decimal that converts to. Right, so we've got one more example where we're given two coordinates and we need to find the gradient between those 2 points. And I might do this both ways as well. So the 2 points are negative 5, 6 and 1, negative 6. So I'll label these again. Let's call this our x1, y1. x2, y2. So that's just so we don't get confused. So the gradient m equals 6. Oh, get it the right way around. y2, negative 6, take away this positive 6, divided by 1, take away negative 5. So I put that in brackets so I don't get confused. So on the top, let's move this down a little bit, we've got negative 12, negative 6, take away another 6, divided by 1, take away a negative is the same as saying plus. 1 plus 5 is 6. So 12 divided by 6 is 2, but we've got a negative and a positive, so it's going to be negative 2. Now, let's just do it the other way around. So, if we swap these numbers, we call that 0.2 and that 0.1, we would have positive 6 take away negative 6, this one take away that one, divided by negative 5, take away 1. So in this case we would get 6 take away negative 6, taking away a negative is the same as adding, so we'd get positive 12 on the top, negative 5, take away 1 is negative 6. So notice here the negative was on the top and the positive was on the bottom, but here it's the other way around, and a positive divided by a negative is the same as a negative divided by a positive, so we'd still end up with negative 2. So don't get confused, don't overthink it. As long as you just treat one point as x1, y1 and the other one as x2, y2, and you plug them into the equation correctly. So the ones at the front is one coordinate, the ones that you're taking away is the other coordinate. You should end up with the same answer. So don't overthink it. I think that's all. So we're going to be using this when we at some point we're going to, well, in the next video we'll be looking at finding the equation of a line. And we may be given 2 points. We're going to need to find the gradient first before we can then convert it into the equation. Okay, so that's where I'm going to leave this one. I hope that makes sense. Just practicing these is the best way to wrap your head around it. Cool. See you.